In this example problem, I would like for us to consider what would be the span of the set of the following vectors. The vectors are 1, 3, 5, 3, 5, 7, and 5, 7, 9. So first off, it should be pointed out that all three of these vectors are within R3. We're going to set up a linear combination of these three vectors. So what we're going to try to determine is the restraint on a vector v, which we'll refer to as the vector xyz, with c1u1 plus c2u2 plus c3u3 being equal to the vector v. Now, for the record, this is assuming that these three vectors within the given set would be u1, u2, and u3. So what we're saying is that c1 times 1, 3, 5 plus c2 times 3, 5, 7 plus c3 times 5, 7, 9 is equal to the vector xyz. Now there are, of course, a couple of ways that we could do this. First thing I'd like to do is use a little shortcut that we talked about in a previous section. Oh, hi, sweetheart. Where the first column represents C1, second column represents C2, and the third column represents C3, and then the vector on the right-hand side represents our vector V. Now the shortcut is I can take the corresponding vector and turn that into the column directly above what we have. So first column is 1, 3, 5, because that's the vector U1. The vector u2 is 3, 5, 7, so that'll be the second column. And the third vector is 5, 7, 9, and that'll be our third column. Now, as far as the vector v is concerned, what we could do is augment with simply an xyz and take it to reduced row echelon form by hand. Now, this is certainly a possibility, and I want to make sure everybody understands we can do this by hand if we want to. Or we could set it up in such a way where the calculator will be able to help us out a little bit better. Unfortunately, we can't put variables like x, y, and z into the calculator. So what we're going to do is we're going to augment with a column that represents x, a column that represents y, and a column that represents z. That way, x could be interpreted as simply 1x plus 0y plus 0z. Same thing for the second row. We can interpret y as being 0x plus 1y plus 0z, and we can interpret z as being 0x plus 0y plus 1z. Then we can take this down to reduced row echelon form using a calculator. Thankfully, in my house, I'm never that far away from a graphing calculator. So let's go ahead and enter the matrix menu. Second followed by inverse key. Arrow over to edit. We'll just go ahead and edit the matrix A. We're interested in a 3 by 6. Going across each row, this will be 1, 3, 5, 1, 0, 0 for the first row. Second row is 3, 5, 7, 0, 1, 0. And the third row is 5, 7, 9, 0, 0, 1. You'll notice that I'm pressing enter after each of these entries. Then I'm going to select matrix A one more time just to make sure that everything that we have in the calculator matches everything that we have written on the page. Now that I've verified that everything looks correct, I am going to ask the calculator to put this into reduced row echelon form. Option B. Then we'll select matrix A. And there we go. The first two rows mean very little to me, but I'm still going to copy them down. What I'm actually looking for is the constraint that we see in the third row. So 1, 0, negative 1, 0, that looks like negative 7/4, and 5/4. Then we have 0, 1, 2, followed by 0, 5/4, negative 3/4. Now the last row, this is where things are interesting to me. To the left of the augment, we have a row of zeros. And again, this is of interest to me. The reason that this is of interest to me is the interpretation of that last row. So what we're saying is 0 times C1 plus 0 times C2 plus 0 times C3 is equal to 1x minus 2y plus 1z. This is what we refer to as a restraint or a constraint. Now, we can interpret this by saying that the span of our set of vectors, I guess we never technically gave it a name, so let's give it a name. We'll call it S for set or span. So the span of S is going to be the set of all vectors x, y, z such that x minus 2y plus z is equal to 0. Any vector in R3 that satisfies that the first component minus 2 times the second component plus the third component is equal to 0 can be expressed as a linear combination of these three vectors. You'll notice that all three of these vectors also obey that constraint. 1 minus 2 times 3 plus 5 is 0. 3 minus 2 times 5 plus 7 is 0. And 5 minus 2 times 7 plus 9 is 0. It is not a coincidence that the given vectors obey what we got for the constraint. Rather, it is expected that it should be that way.